Have you ever wished your phone could just do things for you? I'm not talking about setting a timer. I mean complex, multi-step tasks. Well, get ready because today we're diving into a paper that introduces Mobile Agent. It's an AI that can learn to use pretty much any smartphone app just by looking at the screen. This is a massive leap forward for creating truly autonomous AI agents.
Okay, so check this out. The user gives it a simple instruction. Search the result for today's Lakers game, and then create a note to write a sport news for this result. Just watch. The agent opens up Chrome, finds the score, then, on its own, it pivots to the Notes app and just starts writing it all down. Zero human help needed. This is the holy grail for agentic AI, right? Just seamless, autonomous task completion.
But this brings up a really good question. If we have these incredibly powerful AI models already, why isn't this a standard feature on every phone? Well, it all comes down to a fundamental blind spot that's been holding back this kind of progress for a while.
I mean, really think about it. A model like GPT-4V, it can understand what you're saying, it can see and interpret images, and it can reason about what it should probably do next. So what's the missing piece? Why can't it just pick up your phone and start tapping away?
And right here, this is the crucial point. The AI can decide what the next step is, like, okay, I need to tap the search button, but it has literally no idea where on the screen that button actually is. It doesn't have that precise spatial awareness to turn a command into a coordinate, a place to actually tap. That's the missing link.
So to get around this problem, earlier attempts basically tried to give the AI a cheat sheet by letting it peek at the app's underlying code. But the researchers behind Mobile Agent, they came up with a much more elegant and frankly human-like solution.
And this slide just perfectly shows the huge shift in thinking. The old way, it forced agents to look under the hood, digging through system files like XML to figure out where buttons were. It's super clunky, it needs all these special permissions, and it breaks the second an app gets an update. The new method, Mobile Agent's way, is purely vision-based. It only needs screenshots. That means it can operate any app on any phone the exact way a person would.
Okay, so how does it actually see the screen to find where to tap? Well, its vision system has two really important skills that work together perfectly.
And this breaks it down so well. So on the left, you see it using optical character recognition, OCR, to read every single bit of visible text. We're talking app labels, search results, you name it. That lets it find any word on the screen. Then on the right, it uses icon detection to find all those interactive things that don't have text, like a little heart icon or settings gear. It's this 1-2 punch of reading text and seeing icons that gives it a complete visual map of any interface.
Now, how it finds icons is really clever. The main AI brain doesn't actually find the icon itself. Instead, it just describes it. It'll say something like, okay, I'm looking for the white heart icon. Then it hands that job off to a specialized vision model called CLIP, which is amazing at matching text descriptions to images. CLIP scans the screen and boom, finds the best match. It's a really smart way to divide up the work. All right, so we know the agent can see, but how does it think? This is where its cognitive loop comes in. And it's all about planning, acting, and most importantly, reflecting on what it just did. You see, the agent doesn't try to map out the entire mission from start to finish. Instead, it does what's called self-planning. It's in this constant loop where it looks at the screen right now, checks what it just did, and then just decides on the very next tiny step to take. It's super iterative, and it can adapt on the fly to whatever is happening. But here's what makes this thing so tough and reliable. Self-reflection. If the agent taps the screen and, whoops, nothing happens, it knows it failed. It actually stops, reflects on what might have gone wrong, and then comes up with a new plan. This ability to recover from its own mistakes is absolutely crucial if you want to build an autonomous system that can actually work in the real world.
Let's look at a real example of this. So here, the agent wants to type into the search bar, but its first tap doesn't work. Its observation is, the keyboard didn't pop up. Its thought is, okay, I probably need to click right in the search bar to activate it. And its new action is to do just that. That is exactly how a person would figure this out.
So the theory is really impressive, right? But how does Mobile Agent actually do on real-world tasks? To figure that out, the researchers built a whole new benchmark called Mobile Eval.
And the results, they're fantastic. On simple instructions, Mobile Agent nailed it with a 91% success rate. But even on complex and abstract stuff, like find me a cheap hat, it still succeeded 82% of the time. And the step accuracy is also super high, which means that most of its individual actions, its taps and swipes, were spot on.
This is where it really shows its power, in these complex tasks that span multiple apps. This is one of the hardest things for any AI agent to do. But here, Mobile Agent checks the weather, remembers the forecast, closes that app, opens notes, and then writes a full temperature analysis. It's totally seamless.
Or how about this practical example on an e-commerce site? The user just says to find a cap on Alibaba. The agent figures out how to open the app, search for cap, scroll through all the options, and even starts a purchase inquiry with the seller. It's navigating a pretty complicated commercial app all by itself.
And the versatility is just amazing. Here it is using Google Maps, a totally different kind of interface. It understands the goal is navigation. It finds a nearby gas station, and it correctly figures out which button is start and presses it. This just proves it can adapt to any app's unique design.
So, let's zoom out. What's the big picture here? Why is this research so important for the future of AI, and especially for anyone out there building these kinds of agent-based systems?
So let's just nail down the key takeaways. First, this vision-only approach is a universal key. It doesn't need special access or to read any code, which means it can scale to interact with basically any digital interface out there. Second, self-reflection is the secret sauce. It's what makes these agents reliable enough to use in the real world. It turns them from fragile scripts into robust problem solvers. And finally, for all you developers out there, this unlocks a whole new way to think about building agents. It's a huge step towards a truly hands-free, autonomous agent that can navigate our digital world for us.
I mean, this research just opens up so many possibilities. We're moving beyond simple voice commands to complex autonomous agents that can just do things. It really makes you wonder, once your phone can do literally anything you ask it to, what's the very first thing you'd have it do?
This is for entertainment purposes only.